basic introduction and the basic architecture of Hadoop, where we shall start our discussion initially. A kind request from my end. Can you all please kindly keep yourself in mute? Of course, if you have any question, you can unmute yourself and you can shoot me. But please, thank you. So, well, we'll initially talk about Hadoop evolution and the features of HDFS. We should address how exactly Hadoop got emerged and what are all the outstanding features of the Hadoop distributed file system, one of the major component. So prior addressing about Hadoop, whenever I spell regarding Hadoop, I need to talk about Google. Because if you observe the history, Google is the sole organization which has been even dealing with almost terabytes, and even I can say petabytes or exabytes of data sets. Very huge magnitude of data sets. Perhaps it was $1 million question to the industry to understand how Google could able to maintain or manage its all data sets. But of course, Google never ever revealed its secret out to the nation. For the first time in history, in the year of 2003, Google revealed its secret out to the nation in the form of a white paper, which mentioned that Google follows its own file system for the storage called as Google file system, where it doesn't rely on any other existing file system of NTFS or NFS. It has its own file system called as Google file system. In the very next year, that is in 2004, it revealed another white paper specifying it has its own approach of processing the data sets which were stored in the file system. So that is nothing but Google MapReduce. And these two white papers, what were mentioned, Google file system and Google MapReduce, these two were implemented by a group of people. These two were implemented by a group of people in an open source search engine project where they used Nutch as the web crawler at that level, and they started storing all those web pages in the Google file system, an analogy of Google file system, and started processing them using Google MapReduce. And in the year of 2005, that search engine was a grand success, and they utilized this project for searching of online books. So that was the project. And 2005, it was a grand success. Years later, that is around 2008, Hadoop came into existence, which was named after Mr. Douglas Reed Cutting, son's toy elephant, because that was the person who led this team. And finally, it was made as an open source through Apache. So this is the basic introduction how Hadoop came into the existence and how Hadoop emerged itself as the giant solution. Indeed, I can say the most successful project. Now you can find Hadoop as an open source through Apache, and even you can find the Nutch crawlers still existing. So this is the basic history of Hadoop, how Hadoop came into existence and all things. And now let me even talk about what are all the Hadoop salient features, what are all the outstanding features of Hadoop which fascinated the industry to move forward Hadoop. So I can say the first thing is scalability. Because whenever we talk about the data sets, can you please keep yourself in mute? Again, sorry, please. Please, if you have any question, you can unmute yourself and you can shoot me. But a kind request from my end, please. Please kindly keep yourself in mute. And of course, if you have any question, you can unmute yourself and you can fire me. Please. Right. So what are all the Hadoop salient features? Point one, it is scalability. Because whenever I talk about the datasets are that whenever we are storing the large magnitude of datasets, the technology should be supportive enough to make the storage much scalable. That's for sure. Because let's say at your organization level today you got almost 10 terabyte of datasets, and tomorrow the data rush got increased and the traffic increased, and all of a sudden you got almost 30 terabyte. So whatever the magnitude of datasets that were getting ingested to your organization, your environment, your current infra should be fair enough to handle all those requisites. All those magnitude of datasets should be handled by your existing infrastructure. So it should be scalable enough. And I can say strongly that Hadoop is quite scalable at the environment level, where, as discussed earlier, Hadoop is always at a cluster environment, where a cluster is nothing but combination of nodes connected across a network, and a node is nothing but a simple computer. So a cluster is nothing but combination of machines. Let's say you purchased 5 machines, 5 physical machines, made them as a cluster, and for each and every machine you attached 1 TB of starter storage. So totally, since yours is 5 node cluster, 5 into 1 TB will be 5 TB of installed capacity. Totally it will be of 5 TB of installed capacity. So 5 TB. So let's say the very next day the data rush got increased and you need to scale up your environment to 20 TB. So you can keep on attaching the nodes. Hadoop will give you the privilege to expand your cluster size without even powering down the existing cluster. You need not to power down the existing cluster. You can keep your 5 node cluster as it is running on, and you can still add on the extra nodes so that you can expand your cluster size. And remember, there is no saturation point for the number of nodes that you connected in the Hadoop environment. Your Hadoop cluster might range from a 2 node to 20 node, 200 node, 20,000 node, and there is no saturation point. It can keep on increasing. And the world's largest cluster is so far at Yahoo, comprising of 58,000 nodes. So that is the world's largest cluster. And above all, whatever the machines that you are using is a commodity hardware. Each and every machine will be a commodity hardware, except few machines, because Hadoop has a master-slave architecture here. So the masters, whatever you are going to use in the environment, will be of high-end machines, and remaining all will be the cheap machines. I can say the commodity hardware. Though I specify the commodity hardware, your machines should have the very basic requisites. So let me share you what are all the basic configuration that your particular machine should have in order to get Hadoop installed on top of it. Please verify even your laptops or your PC should also have the same sort of basic requisites. I'm sharing it now. Please verify them. So your machine should have a processor speed of 2 to 2.5 gigahertz. So I can say simply it should be more than 2 gigahertz speed, the processor speed, which is of dual core or quad core with a basic RAM minimal you need to have 4 GB, and better if you have more. Minimal, just verified, it should have 4 GB and 20 GB of available disk space. So these are all the basic requisites that your machine should have. I repeat, you should have 2 to 2.5 gigahertz of processor, dual core or quad core, with minimal 4 GB of RAM, 20 GB of available disk space. So please verify and please make sure by the upcoming Tuesday, because on that day we'll be installing Hadoop on your cluster. Till that moment we'll be going on theoretical. But by that moment, please verify that your machine should reach these requisites. And at the environment level, at the deployment environment, we'll be having the rack servers, where the rack servers should have the speed of 2.5 to 2.7 gigahertz, dual core or quad core processors, which has 1 TB or 2 TB of SATA storages attached, and will be having the RAM of 8 GB or 16 GB attached to each and every machine. So these are all the basic requisites at the production environment. So that indicates the commodity hardware, the cheap hardware. Now all Hadoop is an open source, so you'll not have any issue of licensing, and you need not to purchase the products. So it's an open source, you can even customize them. And flexibility indicates Hadoop can handle any type of data sets. Since you are storing the data sets on top of distributed file system, it can host for both structured and unstructured data sets. And fault tolerance, which is to be the mandate feature for the data sets perspective, because whenever you are storing the data sets at the environment, your specific infra should ensure that the data sets are high available. At any cost, the data should be available for the end user, so giving you the fault tolerance. So at the Hadoop environment also, there is fault tolerance by default enabled. Whatever the data sets that you upload to the cluster environment, I repeat, whatever the data sets that you upload to the cluster environment will be copied thrice by default. That means, let's say you uploaded a file of 100 GB, it's gonna occupy 300 GB of disk space. Well, it sounds like that you are wasting the resources, but not exactly, because you are using the cheap hardware, SATA disks, which costs nothing. And exactly if I compare and contrast the cost constraints between Hadoop storage and the SAN storage, SAN perspective, where you will be using SSDs and FC disks. So Hadoop storage will cost only 34.6% of the SAN expenses. Very, very minimal. And it is efficient, because you have a distributed storage and the parallel processing, which will give you the best performance. And consistency indicates, irrespective of the triggers, whatever you make, you'll get always the similar sort of results. It will not give you any fake results for one attempt to another attempt, and it will not give you any different results for one processing attempt to another processing attempt. Irrespective of the processing attempts, whatever you make, you'll get always the basic same results. And here you have node communication, because you have Hadoop at a cluster environment. They have their node communication, internodal communication is basically present, where nodes will communicate with each other. Whatever the machines that are present on top of the Hadoop environment will communicate with each other, where these nodes follow TCP and IP protocol. Exactly, they will follow IPv4 protocol. And IPv6 will be default disabled on top of the Hadoop environment, to restrict the external communication. So IPv6 will be default disabled, and these follow IPv4 protocols. And it's a shared nothing architecture. Whatever the data you uploaded to the cluster environment, while processing, it will not find any dependencies in processing the data sets as a shared nothing architecture. And above all, Hadoop always requires very less surveillance. Simply I can say you need not to have a sophisticated surveillance environment for the cluster monitoring purpose. Everything is by default automized on top of Hadoop environment. So these are all the, I can say, outstanding features or the most fascinating features for the organizations to look forward for Hadoop. But at the same time, Hadoop has some problems as well. Hadoop has some problems as well. Hadoop has some challenges. Till now, I think from the day when we met until this moment, I have been sharing you only the positives of Hadoop. Let me now talk about even the challenges present in Hadoop environment. So point one, node failures. Since you are using the cheap hardware, Hadoop nodes usually gets failed because of the cheap hardware. And you need to replace the failure nodes with the successful healthy nodes and then make it in the cluster environment. It's a usual issue that comes into the environment. It's quite common. And it is right once. Whatever the data that you uploaded to the cluster environment is right once. You need not to, and you cannot edit the file names, whatever you have. Whatever the file you uploaded to the cluster environment, you cannot edit it in the environment. It's only right once. Perhaps you can even overwrite it. I can say simply, let's say you have 1 million records uploaded into the cluster environment. Updating the 9th record is prohibited. You cannot do that. Rather than that, just give me a moment. Let me attend an important call. Just 1 minute, please. I'll be back within 2 minutes. Just 1 minute, please. Yeah, hello. Sorry. So whatever the file you uploaded to the cluster environment, you cannot edit that. So let's say you uploaded a file of having 1 million records. You cannot update few records. You cannot update the records in that specific file. What all you can do is, if you want to update them, you need to run a map reduce job where the existing data will be edited and the complete 1 million records will be stored into another file which had the 9th record updated. So that's what you need to follow. So you need to design a map reduce job for that. So it is only write once. Perhaps even that will not be supported, or it will not be addressed as a big drawback, because the current distributions of Hadoop, you have even this support. You can edit the individual chunks, provided if you know on which 64 MB split you have your data set, you can edit that, which is a tricky task indeed, but you can do that. And Hadoop is not meant for OLTP. It's not meant for transactions. So there could be one of the impression that Hadoop can be utilized for transactions, vanishing the RDBMS. Perhaps not. Hadoop is only meant for online, offline analytics, not for online transactions. OLTP is not supported on top of Hadoop. It doesn't have any asset properties. Commits and rollbacks were not on top of Hadoop environment. It's not meant for OLTP. It's only meant for OLAP. It's only meant for offline analytics. And Hadoop is only meant for handling the large data sets for parallel processing only. Let's say if you have any data set which you want to process on top of the Hadoop environment, if you want to process the data sets which has some dependencies like Fibonacci series, well, let's say the current computation output will be given as input to the next computation. If you have these sort of dependent processings, Hadoop is not a right approach. Hadoop is not a right approach. Hadoop is only meant for processing the files which do not have any dependencies while processing. It's only meant for parallel processing. And above all, it's only meant for large files only. Hadoop is defined for the files which are of hundreds of GBs and TBs of size. It's not meant for the files which are of KBs and MBs. That doesn't mean you cannot upload those files into the Hadoop environment. You can still upload them, but you'll face a major problem, which will talk about the discussion of uploading small files to the cluster environment within few minutes. So these are all the problems, I can say, challenges of the Hadoop environment. And this is the major discussion where our exact journey gonna be started. So as I stated, Hadoop is always at a cluster level where it has the nodes combination, where they'll be connected through a high-speed network. These nodes will be connected through a high-speed network where the network speed will be at least of 10 Gbps. And they'll follow TCP and IP protocol. Exactly, they'll be following IPv4, disabling IPv6. And whenever I address the Hadoop, Hadoop is always comes up with 5 daemons. Whenever I address Hadoop, Hadoop is nothing but the 5 daemons, where a daemon is nothing but a background service that runs in the environment. And each and every daemon, all these 5 daemons, each and every daemon is nothing but a Java service. So Hadoop requires JVMs to run on. So these 5 daemons were classified as master and slave daemons, where they follow master-slave architecture. You'll have 3 master daemons and 2 slave daemons. Where the master daemons indicates you have name node, secondary name node, and job tracker. The 3 master daemons: name node, secondary name node, and job tracker. These are all the 3 master daemons, and 2 slave daemons, which is data node and task tracker. These 2 are the slave daemons. And in order to have these 3 master daemons will be running on 3 separate high-end dedicated machines. Remember, the 3 master daemons will be running on 3 separate dedicated high-end machines. These are all of not cheap hardware. Master machines are not of cheap hardware. They'll be running on high-end hardware. They'll be running with blade servers, with dual power supply, with SSDs, NVRAMs, and hexa-core processors, which usually go on with 64 GB or 128 GB of RAMs. They are of high-end hardware. Masters are of high-end hardware, and slaves, whatever you connect, will be of cheap hardware. And out of these 5 daemons, the daemons which has the suffix with node, you can see name node, secondary name node, data node. These 3 are responsible for the storage. In it, I can say simply they were responsible for HDFS. These three are the HDFS daemons, and the daemons which are having tracker as suffix, task tracker and job tracker. These two are meant for processing. So they were meant for simply map reduce actions. So here you can see how exactly the environment look like. So here the three master daemons will be usually running on three separate dedicated machines: name node, second name node, and job tracker. They will be running on three separate dedicated machines, but it's optional. You can even run name node and job tracker on a single machine. But name node and secondary name node should never be run on the same machine. We'll talk about it, why it was made so. And on each and every slave machine, you'll be having your data nodes and task trackers running together. So simply, let me share you, just one second. It's not allowing me to draw. Hmm. No, it's not allowing me to draw actually. So let me share it. Let's say you uploaded a file of um, 1 TB. That 1 TB file will be made into 64 MB blocks, and those 64 MB blocks will be stored across these data nodes. These blocks, whatever you can see, the orange colored blocks are nothing with the 64 MB blocks. And if you want to retrieve the data back, definitely you need to know on which node you have your blocks stored on, and that information will be captured with the name node. Name node will maintain that information, where we'll address that as metadata, nothing but details about your data. So that will be stored with name node. So name node knows on which node you have your data sets being stored. I can say simply, name node is just like a index page of your textbook, and data nodes are like the normal pages where exactly your information will be stored. The exact data will be stored on data nodes. Only the details will be stored on with the name node. So if you want to retrieve, or if you want to go through a specific information, you'll open the index page. So in the similar way, when you want to retrieve a file, initially the client contacts the name node, where name node will look on which node you have your information, and the data will be then retrieved back. So the exact data will be always stored in the data nodes. Name node will store the metadetails. The same metadata copy, whatever you have here on the name node perspective, the same metadata, I can say the same index copy will be stored even with the secondary name node, because when your name node goes down, irrespective of your cluster size, whether your cluster is of a 5 node cluster or a 10 node or 50,000 node cluster, no matter, if your name node goes down, you cannot access your data sets back, because if you don't know on which node you have your data sets, you cannot retrieve it back. So failing of name node metadata will not give you any privilege to retrieve the data sets back. So owing to that, the same copy of metadata will be even stored on secondary name node. The same copy of metadata will be even stored on secondary name node, so that when your name node goes down, you can bring a new name node to the environment, and using the copy stored in secondary name node, you can configure that new name node. That's it. When your name node goes down, secondary name node will not act as primary name node. So simply I can say secondary name node is not a failover of your name node. Rather than that, if your name node goes down, you can bring a new name node into the environment and reconfigure that with the existing copy present in the secondary name node. That's how you can make. And job tracker and task tracker, we'll talk about them much in the upcoming discussions. They were meant for processing, so simply. And let's talk about the Hadoop distributed file system, HDFS, which is the major component of the Hadoop environment for the storage. Prior talking about HDFS, let's initially talk why we require Hadoop distributed, or I can say why we require distributed environment. What is the advantage of going ahead with the distributed environment? So let's say you're having the data sets. Just say that you gave me 100 GB of data set. So I stored 100 GB of data set on a single disk. I stored your entire 100 GB on the single disk. The moment when you asked me to retrieve the data of 100 GB, I connected the 100 GB disk to a bus of 10 GB per second. And in order to retrieve 100 GB of data set at a speed of 10 GB per second, obviously I'll consume 10 seconds. I'll consume 10 seconds to retrieve 100 GB of data back from a disk at the speed of 10 GB per second. Now, let's say you came up with a question that you'd like to retrieve the data much more faster. For that, whatever the 100 GB of data I have, I made them into 25 GB splits and I stored 25 GB into 4 disks. So I have 25 GB here, 25 GB, 25 GB and 25 GB. And the moment when you asked me to retrieve the data back, I connected all these 4 disks to 10 Gbps bus and I started retrieving all the chunks parallelly. In first case, it consumed 10 seconds to retrieve entire 100 GB of data. And since I'm retrieving parallelly here, within 2.5 seconds, I can retrieve your 100 GB of data because I'm retrieving the things parallelly. That is one of the major advantage I can say with a distributed storage, so that I can retrieve the things parallelly. Even I can expand this size of storage. But the major problem is after retrieving the 4 chunks, each of 25 GB, I need to be in a position to arrange all these 25 GB chunks in an allied manner so that you can analyze or you can understand your 100 GB of data set. That's a major challenge that I have. I need to know which 25 GB chunk should come first and which 25 GB chunk should come next. And the same issue we have even on top of Hadoop. When your data was stored across the cluster in a 64 MB chunks, you should be in a position to retrieve, you should be in a position to know which 64 MB chunk should come first and which should come next. And that will be taken care by the name node. So name node knows which 64 MB chunk comes first and which will be the next. Because each and every 64 MB split will be awarded with a unique block ID. And basing on that block ID, it will be storing the data sets. So if you want to retrieve them back, so it will come to know which 64 MB chunk will be first and which will be next. So name node will take the sole responsibility of it. So here you can see name node will be looking after your entire cluster, maintaining the metadata and how many nodes were healthy and how many were failed. So everything will be monitored by the name node itself. And second name node, which will be taking the snapshots of the metadata, where if your primary name node was down, second name node will not be acting as the next name node. Rather than that, you can, since you have the copy of the same primary name node's metadata, so you can just bring another name node into the environment and you can configure that new name node with the second name node's metadata snapshot. So that's what you can do. And data nodes will be storing your actual data sets, which is nothing but actual splits. So these are all the functionalities on high level. And why Hadoop is not suitable for small files? This is what we need to talk about. So prior talking about, let me revert back. Let's say one of our friend has uploaded, Mr. Avinash or Mr. Arul has uploaded a single file of 100 GB into the cluster environment. The moment he upload the file, An entry will be created in the name nodes metadata, where that entry will have file name, file size, block size, permissions, user group, timestamp, block IDs. So all those details will be stored in the name nodes metadata. Once after all the entries were made, then the data will be stored across the environment in the distributed fashion. So your data will be stored into 64-bit chunks across the data nodes. So since you have uploaded a file of 100 GB, a single file 100 GB, you'll be having one entry in the name node metadata. But across the storage part, 100 into 3, because 3 copies, 100 into 3 will be of 300 GB. So it will be capturing 300 GB of installed storage. So for a single file, one entry with a 300 GB of storage occupying. And the very next moment, there were 100 people who started uploading 100 files. So each and everyone started uploading one file, where each file is of 1 GB. Each file of 1 GB into 100 files, obviously of 100 GB of storage. So again, that will be also occupying 300 GB of installed storage. But since each and every file is of 1 GB, you'll be having 100 entries in the name nodes metadata. When you have a single file, it was a single entry. But since you have 100 files, you'll be having 100 entries in the name node metadata. And each and every entry will be obviously occupying around 1 MB of storage, because it need to store even block locations. And if you start uploading these sort of silly files of 1 GB or 500 MB or 5 MB, one fine moment, your name node resources will be exhausted. The name node RAM will be exhausted completely. Then you need to come up with another solution where you need to either increase the RAM. So far you can increase it to the maximum extent, and if that is also being filled up, then you need to bring another node into the environment, where you need to make all these two name nodes with a separate configuration called as name node federation, which is a tricky task. And above all, name node is not a cheap hardware, it is expensive. So it's not recommended to store small files into the cluster environment. That was the major reason. And if you still want to store small files into the cluster environment, you can archive them and you can store it. You have that privilege, which we'll be talking about. So you have alternative, which is nothing but Hadoop archivers. And this is the major comment I can say majority of us might have come across. I'm sure everyone might have at least faced this comment once, even in LinkedIn, where people usually post that why majority of Hadoop projects were getting failed. They usually come up with the simple answer, Hadoop lacks security, and that was the major reason why Hadoop projects are getting failed. And majority of your colleagues might have poked with the same question. Hadoop has the very less security. Let me share you. In fact, Hadoop doesn't have tight security. It's true. Whatever the raw Hadoop you come across, let's say if you download a raw Hadoop, once after making it into the cluster environment, the basic security will be on top of the user management. You'll have only the user level security because you have the permissions and user group. Only you will be having that security. But perhaps while talking about the production environment, definitely there should be even more tight security. For that, when Hadoop was installed with Kerberos, Kerberos is an authentication software through MIT. It's for freeware. You can even download that. When Hadoop comes up with Kerberos by default, it will give you the most tight secured cluster. Let's say you have 100 nodes, and once after you have installed Kerberos on top of your machines, in order to contact your machine, there will be a center for Kerberos called as KDC, Key Distribution Center, where all the client machines who usually access your cluster, all those IP addresses will be stored on the KDC. Once if the client want to contact the cluster, he should initially get connected to the KDC, where Key Distribution Center will be sending a file called as key tab file to the client, and using that key tab file he can connect to the cluster environment. If any other new client whose IP address was not configured with the KDC, Key Distribution Center, he cannot connect to the cluster environment. So you have the basic, not even the basic, you have the sophisticated authentication through the Kerberos. It will give you the most tight secured cluster. And even you have the block level integrity, because you might even come up with one of the comment that since you are using the cheap hardware, it's quite common that the disks might get corrupted because of several reads and writes. So I can share you simply that, let's say when you uploaded a file of 1 TB, it will be having 60 from B chunks. It will be having something like 60,000 60 from B chunks. Each and every 60 from B chunk will be pre-calculated before you upload to the cluster environment. Name node will be calculating something called as checksum on each and every 60 from B block, where a checksum is nothing but the byte offset present on each and every block. So for each and every block, checksum will be calculated and will be captured, will be stored in the name node. Once after the file was retrieved back, let's say you retrieved a file back, again when you submit the file back to the cluster environment, checksum will be again calculated. Checksum which was calculated after your file read and checksum which was calculated before the file write, both will be compared. And if the checksum was matched, no problem. Hadoop will consider that the file was absolutely fine. If the checksum doesn't match, Hadoop will by default raise an exception called as checksum mismatch exception, which will convey that the specific block was corrupted. And though if the block was corrupted, no need to worry, because you have still more 2 healthy copies. So though if one of the block was corrupted, you have still 2 more healthy copies, using which it can make 1 more copy, giving you the tight failover on top of the Hadoop environment. So let's say if the block was failed, so no problem, you have 2 more healthy blocks. If the block was corrupted, you have 2 more healthy blocks, using which you can provide uninterrupted service to the client. So let me share you on finally, if Hadoop really lacks security, Wells Fargo, Bank of America, PayPal, these are all will not be the clients for Hadoop, because those are all the organizations where you have the tight and most confidential data sets being handled by. If Hadoop really lacks security, definitely they will not be becoming the clients for Hadoop. So Hadoop will give you the tight security on top of it when you come up with this Kerberos authentication and all the things. So this is the basic part, what exactly Hadoop is and what are the distributed file system, the features of Hadoop, and even the problems with Hadoop and security layer on top of Hadoop. And tomorrow we'll talk about how exactly a file will be uploaded to the cluster environment, how it will be retrieved back from the cluster environment, and then we'll talk about what are all the functionalities of name node and how the communication actually happens between name node and data nodes. So tomorrow we'll continue our journey where the focus will be at these areas. And prior moving ahead, just let me know any questions so far or anything unclear from my end. You can unmute yourself and you can fire me with your questions.
Hi Vignesh, this is Rahul.
Hello.
I have a
Yeah,
few
hello, Mr.
questions.
Mr.
Yeah, I have a few questions
Yeah,
regarding today's session.
yep.
The first question is like we talked about some disadvantage, like a fault tolerance in Hadoop system.
Ha. Yes.
So you said every record it will be like make it as a three copies.
Yes,
So
absolutely.
when you are processing the data, so which one will be take as a main file? Like we have a three copies. So when you
So
are
will it, huh, which
yeah,
copy will be processed?
right.
It will definitely not process the duplicates. That's for sure
Hmm?
because it will create a deadlock on top of it.
Okay.
So while processing, let me share you have a concept called as availability of slots.
Okay.
Let's say you have a 100 node cluster and you uploaded the file to the cluster environment. So
Hmm?
making your file into three copies, your data will be stored across 100 nodes. And while
Hmm?
processing, if you want to process it, you'll submit a request to the job tracker. And
Okay.
job tracker will look on to the nodes where it has some RAM and processing resources vacant. Because if you want to process, definitely you need to have some RAM and processing resources vacant,
Right.
right? So wherever it finds the availability of RAM and processing resources on
Hmm?
that node, if you have your copies, those copies will be processed. So wherever you have availability of resources, that will be coming up with the availability of your data as well as availability of resources. Wherever it finds, then the processing will be initiated. We'll delve on top of it much more detailed when we talk about the map reduce part.
Okay. So basically it identifies the main record and it will be processed, right? The job tracker will be process the main record.
Main record in the sense?
Like if we have a three copies, so either one of them should be the main one, right? Main
Yes.
file.
No, no, not like that. Because
Okay.
no matter whether if I just give you Xerox copies of let's say I have a single page and I gave you two copies. So totally you have one source file with two copies. The matter will be
Okay.
the same, right?
Okay.
Matter will be the same. So wherever it finds the availability of slots. So let's say on the root or the source file, you might not have any of the resources available because there might be several other files being processed. So you have still more two copies. So basing on the availability of resources, wherever it finds the availability, there it will be processing the things. It is not confined to the source or the copy. It will not be confined to that.
Coming to the other question, the node slave, you said it will record every entry whenever you insert a data sets, like it will make a some
Yes.
unique ID for every record. So
Block. For each and every
yeah,
block, there will be a block ID. Huh.
okay. So for these three copies also, will it make the ID or will it be the same ID for three records?
Definitely.
Okay,
Definitely. It will be having the similar sort of ID with the different extension methods.
extensions.
Only the
Okay,
extension varies, yes. But the block ID will be
okay. And the other one is like node communication. You said we only go with the IPv4 protocols.
exactly.
But going forward, like we are have IPv6, will it be compatible with IPv6 protocols like Hadoop system?
No, by default, Hadoop comes up with only IPv4. They have only IPv4 protocols. Still, they were following with IPv4 only.
Okay.
IPv6 will be disabled actually. On the production environment, IP tables will be powered off. We'll do that even when we just come up with the cluster building part. We'll even
Uh-huh.
power off the IPv6 because not to restrict the external accessibilities of the cluster,
Okay.
restrict others to access the cluster. So for that, IPv6 will be disabled. These nodes will follow IPv4 protocols. Perhaps you will
Okay.
not find any performance issue, though they follow IPv4 or IPv6.
Okay.
They'll be having uninterrupted protocols and the cluster will be up and running. They'll be following something called as heartbeat mechanism for it. We'll talk
Mhm.
about the heartbeat mechanism, how the heartbeats will be going on and how the signals will be transmitted across these nodes.
Okay, the other one is like we talked about shared nothing architecture feature. So what does it mean,
Yes.
like shared nothing architecture feature?
While processing the file, let's say when you uploaded a file to the cluster environment, you have
Mhm.
multiple 64 MB splits. While processing, it will not wait for the other 64 MB split to process. Each and every
Okay,
64 MB split will be processed individually parallelly. So it will not find any dependency. It will not be waiting for any other process to finish and then processing it. It will not be sharing any of the documents between these blocks again,
okay.
independently.
And other one is like we have some challenges like it's only for OLTP.
Yeah, OLAP, not for OLTP.
Okay,
It's not for OLTP. Yes.
okay. So OLAP is like for online transactions or what is it like
No, no.
OLAP?
OLTP indicates online transactions.
Okay,
OLAP indicates offline analytics.
okay,
It's only for analyzing the large data sets. Once after you have your data sets,
okay,
let's say you're talking about a banking client, where
right,
several transactions, whatever you made, will be reflected on top of the database.
okay,
If you want to analyze those transactions over a period of time, you'll be ingesting all those transactions to the Hadoop environment, where you'll be using Scoop for that. You'll be
okay,
populating all of them to the Hadoop environment. Then you'll be
mhm,
processing all of them at once,
okay,
right? So that is what we call as analyzing those data sets. OLTP
okay,
comes up with when you just make a transaction, whether your transaction was successful, failure. So
okay,
whenever the action was successful or failure, so everything that comes with the transaction. That will be
okay,
stored on the OLTP databases.
okay. So the other one is when you say large file, we only process the
Mm.
large files. Is there any limit for
Yes.
the file size? Like what is the minimum file size should be?
Usually, there is nothing like minimum file size. Larger the file size, better the performance you have. That's it. Better
Okay,
the lifespan, larger the file. That's it. There is no such constraint that there is no such threshold limit. I can say beyond this threshold limit is a larger file. Below this, it's a small file. There is no such considerations. We usually address the files which are of hundreds of GBs will be a large file.
okay.
That's a large file.
So coming to the security, like you, checksum, will it is it checksum is basically is it comparing the file size, importing file size with the block size, or is there anything that we have?
Checksum for each and every 64 MB split, calculating the byte offset is what we call as checksum.
Okay.
The moment when you upload the file,
Mhm.
calculating the byte offset is what we call as checksum for each and every block. That will be by default calculated by the name. And once if you retrieve the data back, the previous checksum which was already calculated, and after
Right.
your submission, the checksum will be recalculated, and the recalculated checksum both will be compared. If they were
Okay.
matching, definitely there is no information missed on top of the block. If they were not, that indicates some of the information got missed because of the
Okay.
wear and tear of the, because it's a mechanical device. Disk is nothing but a mechanical device where it usually gets corrupted. It's quite common. So
Okay.
owing to that, for the data integrity, we have checks.
Okay. Got it.
Yeah,
Yeah, that's all from my side.
right.
Thank you, Vignesh.
Thank you. Any more
Uh,
from anyone? Yeah, please.
Vignesh, this is Raj here.
Yeah, Mr. Raj, please tell me.
I just want to know, like you mentioned, like a name node and also like a secondary name node. What exactly this
Yes.
secondary name node useful?
So let's say secondary name node is just for housekeeping purpose simply. So
Okay.
whatever the metadata details that were stored on top of the name node, the same
Mm-hmm.
copy of metadata will be stored in the secondary name node also. It's
Oh,
only
that,
not for the high availability feature. Let's say when your name node goes down, definitely
okay.
the copy of the metadata should be stored somewhere else. Then
Mm-hmm.
only you can bring a new name node into the environment and you can configure that new name node as that of your primary name node. For that,
Got it.
you have that copy made with the secondary name node. And we have much more to talk about secondary name node. Not only that, because
Mm-hmm.
the metadata will be always stored on the RAM and at the range of FS image, which will be stored on hard disk, In order to keep both of them in sync, secondary name node will play a predominant role. So we'll talk about that, how it happens and all the things.
Oh, okay. Yeah.
Yeah.
Hi Vignesh,
Yeah,
this is
please.
Vishnu.
Please tell.
Can you say about rack server? You said that production environment, the rack server has
Sorry?
rack server. I mean like a rack server. You said that right? In the production
Yes.
environment.
Yes.
Can you say about it? What's the use of it actually? I mean like the configuration is set that way.
I don't get you. So you mean to talk about what does the rack server configuration comprise of? What are all the basic requisites of the rack server?
Yeah,
Is that your
exactly.
question?
Yeah.
Yes. Usually this rack server will be having SATA disks. We'll be attaching that with SATA disks where
Okay.
it will be of 2.5 or we'll go on with 2.7 gigahertz of processor, which are of dual core and quad core processors with minimum of 8 GB or 16 GB of RAM with 1 TB or 2 TB of SATA storages, SATA disks. That's all the configurations that will go on with the production for each and every rack server. Where rack
So
server
when
will be
executing
used as a cheap hardware here. That's for sleeps. Yeah, please.
when executing this project server, I mean like the system has to be like this configuration, right? For this.
Yes, your specific machine, let's say your laptop or your PC, should have these basic requisites where it should have at least of 2.5 gigahertz of two, I can say more than 2 gigahertz because it's our single node. Whatever the cluster we are going to build will be running all your daemons on the single machine. So we need to have at least of 2 gigahertz or even more of processor speed, dual core or quad core, right? With 4 GB or 16 or 4 GB or 8 GB of RAM with 20 GB of available disk space.
And this daemon runs in a cluster, is it? So it's in background
Sorry?
runs in JVM background. I mean
A
daemons.
daemon, yes, a daemon
Yeah.
is nothing but a background service that will always run on top of the cluster environment. Once if you power on your cluster, you'll be starting all these daemons. All these daemons will be running by default on top of the cluster environment. Until and unless you power off your cluster, all these 5 daemons will be always up and running.
Yeah. Yeah. That's it. Yeah. Thank you.
Right? Yeah, thank you.